In this video, we're going to talk about meso compounds. Let's take the example of a Fischer projection that looks like this. Is this a meso compound or not? So the way you can tell is if there is an internal line of symmetry. If you draw an imaginary line right there, both sides of the line are identical to each other. You have a bromine, you have a methyl, and you have hydrogens. They're both coming out of the page because that's how Fischer projections work in terms of the bromines and the hydrogens, and then you both have methyls on the other side. So these two sides of the molecule are identical to each other. So therefore you have what's called a meso compound. Now let's go over what is not a meso compound. What is not a meso compound would be if you have a structure looking like this. In this situation, if you draw the line of symmetry, you can see that the bromines are on different sides, and so are the hydrogens. So this would not be a meso compound. Now you need to understand that meso compounds, they are considered achiral, even though they may have chiral centers in them. Because of the line of symmetry, they are achiral, and they are also optically inactive. Now, if something is not a meso compound, then it is going to be optically active. So just memorize that. Now let's go over a few more examples. Would you consider this structure to be a meso compound or not? So if you draw the line of symmetry right here, you can see that both sides are the exact same. So therefore this would be a meso compound, and it would be optically inactive. How about this structure? Is this structure a meso compound or not? So this structure is not a meso compound because you can't really see an internal line of symmetry. So therefore this structure is considered to be optically active since it is not a meso compound. How about this structure? Is this structure a meso compound or not? And specifically, you can put wedges on the alcohol groups. So this structure, if you draw the line of symmetry, actually is going to be a meso compound. So it is going to be optically inactive. Now, if we were to draw a similar ring as to the last one, however, this time put a dash on one alcohol and put a wedge on another alcohol, would this still be a meso compound, or would it no longer be a meso compound? As you can see, both sides of the line of symmetry have the same exact atoms. However, this one's on a dash and this one's on a wedge. This one's coming out of the page, this one's going into the page. So therefore, these would not be symmetrical, and they would not be meso compounds or meso compounds. So these are going to be optically active. Now for our last example, let's go over a quick Fischer projection. Would these two be meso compounds or not? So usually, if you draw the line of symmetry, you can see that we have the same iodines on the same side, the hydrogens are symmetrical. However, we have an ethyl on top and a methyl on bottom, and you can't have that if you're trying to be symmetrical. So this would not be a meso compound, and it would be optically active.